Anybody out there can give you the marketing spiel on the cloud. You're probably bombarded with all kinds of stuff like, you should be learning the cloud. If you don't learn the cloud, you'll be dead. You won't have a job. You're a dinosaur. Here's the thing. The cloud changes every 3 months, every 6 months tops. I'm continuously rewriting this deck because everything changes. If you don't learn one thing about the cloud, your career is fine. You will need to learn it someday. You just don't have to learn it today. Even if you do learn it today, you're going to relearn the bejesus out of it every 6 months because everything changes so frickin' quickly. Having said that, there are things I think that you should know about the cloud, not necessarily the specifics of how it works, but what the big picture stuff is, so that you don't look like a buffoon when the developers come in and talk to you, or when management says, I think we should use the cloud. The goal of this next hour is for me to explain the differences between platform as a service and infrastructure as a service in a way that means something to you as a senior DBA, and to give you a route forward across one of those and explain why it's going to work for you and what's going to be different about it. Platform as a service and infrastructure as a service are two terms that the industry uses. I'm going to break it down as simply as I can. On the left-hand side is infrastructure as a service, IaaS. This is nothing more than virtual machines. Amazon's called EC2, Azure calls theirs Azure VMs, Google calls theirs Google Compute Engine. They also have a Google Cloud that's GC and Google Cloud Platform, so the initials get kind of confusing. But all three of those there are roughly identical. They do offer slight edges in different ways. Some are better on networking, some are better on larger storage, some are better on faster storage, some are better on snapshots. And it all comes and goes fairly quickly right now because we're very much cutting edge. Now, as you go down the left-hand side, you'll notice who does what on each of those. And in everything, it's you, because it's just VMs. You're the one who has to manage HA. You're the one who has to manage DR because you're installing SQL Server and running whatever features you want on there. If you wanted to run a 10-year-old version of SQL Server or a 20-year-old version of SQL Server, you can. It is entirely up to you. You can do anything that you want. They're just VMs. Over on the right-hand side is something different. This is Amazon's relational database service, or Microsoft's Azure SQL DB, or what used to be called SQL Azure. In this case, you are paying, and I almost want to say extra, but that's not always the case because it can be way cheaper. But you're paying them by the hour to manage everything for you. They're managing the backups. They're managing high availability. They're managing disaster recovery. You don't have to know about corruption. You don't have to know about CheckDB. These things are just happening for themselves. But that bottom right thing is kind of interesting. Who can get to the backups? Because you can't. Think about this in terms of how your developers usually approach you. If a developer said to you, I'd like a copy of last night's data warehouse backup, you would give them the finger, right? You'd be like, what do you think you're doing? No, you don't have any business doing that. You go do developing. You do get data in and out of the database. That's exactly what Microsoft is saying to you. No, you don't need the backup file. We're taking care of your backups for you. You just go get data in and out of the database. You'll notice that I said in there AWS you can, but there's a giant asterisk involved with that. With Amazon Web Services RDS, you can access full backups if you take them out of band. If you go take your own full backup, you can point it to an S3 bucket, which is kind of like a file share. You can point it at a bucket and then go grab that back file yourself. You can also give them a back file. Hand them a back file and they will restore it for you. Microsoft, that's not the case. They don't want anything to do with back files. They're not giving you one. They're not going to take one from you. So this starts to have other infrastructure changes as well, or things that are different between these two platforms. Over on the left-hand side with infrastructure as a service, you get any database features you want. You're the one managing the database. It's all you. If you want standard features, if you want enterprise features, whatever you want to buy, you can get. Will you need a DBA? Well, yeah, because it's just VMs. but you can move your data in and out of the cloud any way that you want with infrastructure as a service. That is not the case with the right-hand side. You cannot just give them a full backup and your log backups. It's not like you can log ship up to the cloud. It's not like you can database mirror up to the cloud when we're talking about platform as a service. Those things are radically different. That alone usually makes Azure SQL DB pretty much a non-starter for everybody. Everybody who's got existing applications, like in a senior DBA class, people don't go, what do you mean I can't take a backup and just hand it to Microsoft? What do you mean I'm going to do a bunch of insert statements and BCP? That doesn't make any sense. So in the senior DBA realm, in this class, senior DBAs get really excited about infrastructure as a service because it's nothing more than a bunch of VMs and you're paying someone by the hour to manage the hardware. I bet in your company, you probably have separate teams who manage Windows and who manage systems and who manage VMware. You may not even have permissions to talk to those people. Well, infrastructure as a service, it's just that those people work for another company. They don't work for your company. They work for Microsoft or Amazon or Google. It's just like the team-based approaches you're used to. Whereas platform as a service is not targeted at you. Platform as a service is targeted at developers. Developers who are used to hearing the DBA say no. Can I get access to? No. Is it okay if I turn on? No. Developers are totally cool with this because they're used to DBAs telling them no for the longest time. Now it's just that the DBA works on a different team. So infrastructure as a service really resonates well with folks like you, people who are senior DBAs. You can run anything you want. You can get any kind of hardware you want in there. You can set it up any crazy way that you want to. Whereas with platform as a service, it's not really for people like you. It's for people like developers who are used to using a subset of SQL Server's functionality. There's no negotiations. Either something is on or it's off, and there's nothing in between. Developers are fine with that. They're used to being told no. DBAs are not okay with that. So here in one slide is how you know whether or not you should be on infrastructure as a service on the left or platform as a service on the right. Can you fail over back and forth between their cloud and your data center? Yes, if you're building your own VMs. No, if you're dealing with these services. Remember, they're kind of locked in like a Hotel California type thing where you're not getting access to database mirroring ports or availability group ports. These work best when your primary database server can be anywhere. You can run primary database server down on premises if you want. You can run the primary up in the cloud if you want. However, with platform as a service, your primary and your secondaries need to be in their cloud. This is really designed for the all-in bet when your developers are saying, let's just run everything up in the cloud. Your application servers always need to be in the same place as your database servers. In theory, you could run your cloud SQL or SQL Server up in the cloud and your app servers down on premises, but then you run into a little problem that we like to call latency. Everything runs really, really slowly because you don't want to wait on a round trip up to the cloud every single time you need to run a SQL query. This is really best for systems administrators, folks like you. This on the right, it makes more sense for developers. I don't expect from here on out to hear any of you say, tell me more details about platform as a service. But I'm going to tell you the bare minimum of what you need to know when you talk to your developers. I don't expect you to use it. I don't expect you to learn it. I think it's awesome. I actually use the one on the right for our own internal development at Brent, Ozar Unlimited. Because I don't want to manage databases. I don't want to manage patching. I just want to connect to something and have it work. Because after all, I got a day job, right? I'm trying to teach people about SQL Server. I'm trying to make it go faster. I don't want to hassle with backups and CheckDB and scaling out and picking versions and patching. I'm just going to let the vendors do that for me. However, if you're a database administrator and you're not building things, then it's much easier to go with the one on the left. So let's talk about what platform as a service means. There's two big players out there. Amazon's RDS, Relational Database Services, works with SQL Server. They also have flavors for Postgres, for MySQL, for Oracle, all kinds of other database platforms. Microsoft Azure SQL Database is said to be built on the same code base as SQL Server. It's mostly the same as SQL Server, just has a few different sometimes small, sometimes fairly large differences. In both cases, when you're developing a brand new app from scratch, what my developers will go do is just go deploy the app up there and see what happens. Because some of these vendors have showstoppers. For example, if you're doing CLR inside the database, or if you want to do linked server queries, you'll learn very quickly which features are or are not supported on any given vendor. Then, after you've deployed up there just to see if your app works, if it works with both vendors, try to use features that are going to be supported by both vendors. Try not to build in support for something that's going to lock you into one cloud vendor permanently. Because after all, sometimes cloud vendors have been known to raise their prices dramatically overnight once you happen to be locked in for something. Google App Engine was notorious for this. When it first got started, it was super cheap, then tended to jack up their prices hugely overnight, and people just didn't have a choice because they'd hard-coded a lot of their stuff for Google App Engine. When you're building out your applications, the platform as a service works best if you think of every database as a totally self-contained silo that can move around from one place to another. Don't think about it as being several databases on the same server, because often they won't be. You can't do cross-database queries the way that you're used to doing them in SQL Server. You can't really do linked server queries the way that you're used to doing them either. You can join results from databases together. It just takes so much more work that it's easier if you come in with the approach of each database is a standalone entity. Now, which one between those is cheaper? People think that they're going to make the decision based on which one is more or less expensive today. This is going to sound weird. It doesn't matter. They're both in a race to the bottom. Both Microsoft and Amazon are racing to cut their prices as much as they can. And what's cheaper today may be totally different 3 months or 6 months from now. But just to give you a rough idea of what costs look like, I'm going to take Azure SQL DB first. Azure SQL DB offers basic, standard, and premium tiers. And they're based on database sizes. This is actually a little bit older of a screenshot. Their largest database tier goes up to 4 terabytes now, just inside of one database. And look at this. This is how you really decide which one is right for you. How fast do they go? This one goes up to 5. This one goes up to 100. This one actually goes faster than that now. But what does that mean? What's a database throughput unit? Database throughput unit is a synthetic transaction speed benchmark that Microsoft uses and does not share with you. It's just some benchmark that they gauge transaction speed at. And when your transactions are running, they convert them, so to speak, into how much CPU, how much memory you're using, how much storage space you're using, or how much storage throughput, scanning you're using, to give you a rough DTU number. This is meaningless for me. I can't convert things to DTUs directly. So what I'm going to do is I'm going to take Azure SQL DB's pricing, and then I'm going to put it up against Amazon's and explain what the hardware looks like. So with Microsoft, a P1, which gets you about 100 DTUs, costs about $6,000 per year. This is for one database. And I know what you're thinking. Oh my God, that's a lot of money for a database. But they also have tools like elastic pricing that will let you pay one price and run several databases inside there, divvying up the transaction throughput across all of them in the pool. That gets a lot more complicated. I'm just going to keep it simple for right now. You'll notice is that you go from 100 DTUs to 200 DTUs, the price basically doubles. So you're paying for exactly how much performance you use. And if you add a readable replica, your price also doubles. It's really simple and straightforward. You're paying for what you use, and the more you use, the more you'll pay. I love that as a database administrator and a performance tuner, because I can come in and make a real difference. I can come in and look at what are your most resource-intensive queries, what are your ugliest indexes, and if I do good performance tuning, I can drive your bill down the very next day. I can make it possible so that you can go on a much smaller instance size. But that can bring us back to this question of what are you paying for with this? How much hardware is actually involved with each of these numbers? Because DBAs usually think in terms of hardware. In order to map that out, I'm going to take Amazon RDS's pricing. RDS, the relational database service, lets you run up to 30 databases on the same server. So the pricing doesn't map one-to-one, but I'm just trying to sketch out, if I spend, say, $6,000 at Amazon, what kind of hardware am I getting? So to see that, I'm going to take the exact same chart, and then I'm going to layer in Amazon's pricing. Now, I am doing Amazon's on-demand pricing. With Amazon, you can prepay ahead of time. You pre-book for a much larger chunk, and then you can get a huge discount. 50% isn't an unreasonable discount when you prepay for, say, a year or 3 years. That takes away a lot of the advantage of the cloud to me, but it has some advantages in the right big business models. If I spend about $6,000 a year for an RDS instance, I am getting 1 core and 4 gigs of RAM. This is where DBAs start to go, oh my God, this is a ripoff. But remember, they're paying for the hardware, they're paying for the patching, there's reliability underneath that you don't see, redundancy built in that you don't see. All of this stuff is running on shared storage, for example. And as you start to march up larger, you get larger instance types. But these aren't really huge, amazingly big instance types. The cloud isn't a way of saving money if you have a predictable demand. If you have exactly the same demand all the time, you're probably not going to save money by moving up into the cloud. But where it's awesome is when you have unpredictable demands. If you have the Black Friday workload, for example, and you need to put a whole bunch of horsepower behind your SQL servers, but only for 48 hours, or another client that we have, tax preparation. On tax day, you need a whole lot of horsepower, but then it's sitting idle for the rest of the year. Martha says, do the platform as a service include licensing? Yes, there's no license charges whatsoever with that. They're included in there. So again, it starts to seem cheap when you compare it to Enterprise Edition. Jumping back one there, say that you use 8 cores here and 61 gigs of RAM. If you're looking at big, beefy features, then that starts to make a little bit more sense. You're talking $16,000 just for the SQL Server licensing up front. The platform as a service has a few dark sides. The biggest one is I want a copy of my database. My developers are very accustomed to saying, give me a copy of production, because they want to be able to run tests. What you do is you take last night's snapshot backup or whatever point in time backup you want up in the cloud, and you go spin up a new database server up in the cloud. Except there's no such thing as a developer edition box up in the cloud. Everything is production. Azure recently introduced this really slick new way of doing it, an RS, a reduced redundancy instance, where you pay a little, well, in this case, a lot less, but you get a lot less redundancy. It has a much higher propensity for failure. Totally fine for my development environments that I can recreate from scratch. Someone else also manages the versions. They pick which service pack and cumulative update you're on. They will update you. They will update you on their schedule, not yours. You get to pick your preferred downtime windows, but you don't get to say, I need you to skip this Saturday's update. When that Saturday's update comes out, it's coming out. Whatever time you picked, that's the time it's going to come out. If you want to stay on an older version of SQL Server, sorry, that's not an option. Microsoft patches when they want to patch, same thing with Azure. And when I will give the vendors plenty of credit, especially Azure SQL DB, they will communicate a long time in advance when they're making what they call big breaking changes. They'll give you lots of time in advance to say, on this date, we're going to change this about what you're using. But that's when everything's working perfectly. Sometimes, like I've got on the bottom of the slide here, in April of last year, Microsoft removed support for CLR in the database with 1 week of notice. Meaning, because they found a security risk, if your application depended on using CLR code in the database, you had 7 days to find some alternate solution before they would shut you off. In their credit, you could make calls to your customer support rep, and I've heard people supposedly could get on a whitelist and continue using CLR for some period of time. But with 1 week notice, that's a heck of a scramble to go jump into. Here's an example from yesterday, if I believe right, this was, yesterday. I got an email from Microsoft yesterday saying, hey, Brent, we noticed you're using database threat detection. And the way that you have it configured was the only option initially, but now you have 3 weeks before we're going to change it and make it not work anymore. I call this the hamster wheel of the cloud. Once you get onto it, you're committing that you are going to continuously put effort into staying compatible with whatever versions they're bringing out today. You don't have a choice. You are going to obey whatever they say. This is the database administrator as a service. If your DBA tells you you're going to do something, sometimes you don't have a lot of choice. Someone else manages capacity. Whatever the max database size is, it's hard-coded. For the longest time in Azure, it was a 1 terabyte database. Now they've raised it to 4 terabytes, which, let's be honest, is actually really good up in the cloud. Most of us don't have 4 terabyte databases that we need to manage. And the cloud vision is that you start to separate your databases out by shards. It's just different. That's designed for developers, not for us as an audience. So to recap platform as a service, this really is not designed for you and me. I know you'll see a lot of bloggers and presenters out there who say that you have to learn this or you're a dinosaur. What they really mean is that developers, people building new applications, do have to learn this because it's the right way to host a lot of new applications out there. Not all, because a lot of us have on-premises applications that we're not allowed to put up in a cloud. But if you're a developer building a brand new application today, you should be learning this. This is awesome. But that's not what this is. This course is the Senior DBA course, and this is the component of the cloud that you are much more likely to use. Infrastructure as a service is catching on like wildfire, both amongst small companies and big, huge, large enterprises. For the most part, it's just virtual machines. It's the same virtual machines you know and love today. Well, maybe love is a strong word. I know and love virtual machines today. We talk about in the performance tuning class when it's the right time to switch over to bare metal, but most databases could probably start just fine on VMs and do really well. There are a few key differences. First off, licensing by the host. In large enterprise shops, they like to license VMware for a physical box and then license SQL Server on that physical box. And then you can run as many virtual machines as you want on that box. That's not how it works in Microsoft's cloud. In Azure VMs, you're just getting VMs, but you have no idea where they're running. So you have to license every single guest. I believe they're going to fix that. I believe they're going to change it. It's probably not going to be tomorrow, but Amazon did already fix this. Amazon brought out something called dedicated hosts. These aren't perfect. They have a huge flaw that I'll talk about on the next slide. But the idea is you rent a big beefy box from Amazon, you license SQL Server on it, and then you run a whole bunch of SQL servers on that host. The big beefy problem with this is you don't get to choose exactly what kind of host you're renting. You can get, these are the choices that you have as of April 2017. You can get 2 socket boxes with 20 cores, hello licensing. This means you're going to be licensing Enterprise Edition across, this is two 10-core CPUs. So 20 cores worth of Enterprise Edition, roughly $140,000 to license this host. It is real money, but when you talk about enterprises licensing VMware hosts, this isn't unusual. Then notice that you get a specific set number of instances that you can start, and that's it. You can't, for example, run 32 medium guests on a G2 instance type. If you want 32 medium guests, you have to step up to an M3 instance type. So you have to do some capacity planning, sketching out how large your VMs are going to be. You can't pack them all in like a clown car the way that we're used to doing them on premises. There's a great saying in the cloud. In the cloud, treat your servers like cattle, not like pets. When we build SQL servers, we're used to treating them like pets. We name them a certain thing, we install just the right tools on them, we teach them all our favorite tricks, and we assume that they're going to live forever, and we're very heartbroken when they die. In the cloud, you just expect your cattle to live and die all the time, and you wear their skins as clothing. That's not true. What I mean here is that you want to think about backing up data, not servers. Your servers are disposable. They will disappear. You need to be at peace with that. And think about your infrastructure as code. Can you script out everything you need to do in order to go build a new SQL server very quickly? Because your SQL servers will fail. It's just a matter of time. Snapshot backups are also different up in the cloud. On premises, tomorrow we're going to talk about how you do SAN snapshot backups and grab a snapshot of a very large database very quickly. Up in the cloud, the capabilities are very different. Azure does have snapshots of managed disk VMs, but they come with some very high price tags around how you get enough throughput for a very large database. With Amazon EC2 and Google Compute Engine, it's not even an option. All snaps are at the single volume level, and you can't usually get out of just one disk all of the throughput that you want in order to make end users happy. See, up in the cloud, the normal way to get lots of performance out of your storage is to stripe together lots of disks into one big virtual drive. Think of this as RAID 0 done at the Windows operating system layer. And when I say this, immediately DBAs just freak out. What do you mean RAID 0? Remember, up in the cloud, treat your servers like cattle, not like pets. You expect them to be disposable. They will fail. You just need another SQL server in another data center up and ready to go. Because that storage is so expensive, especially to get it fast, the vendors also offer local solid-state storage, ephemeral storage that will disappear whenever your VM disappears. Stop your VM and then go to start it again. Whatever's on those disks may be gone. Not maybe, is gone. Which can make sense for TempDB, because after all, TempDB gets reset every time that SQL Server restarts. I just have to be careful with how I start up SQL Server. Say that temporary disappearing drive is the Z drive. In terms of Windows, I open Windows Explorer, it shows up as the Z drive. Every time I start it up, if I kill that VM and then start it again, that Z drive is empty and there's not even a folder in it. So if I have TempDB to go into Z MS SQL backup or MS SQL data, then TempDB, if that folder doesn't exist, SQL Server won't start. So you have to make sure to have some kind of script set up to check to see if that folder exists. If not, go create it, then go start the SQL Server service. There are even shops using Ephemeral for their databases. That's right, their user data and log files they are knowingly putting on local solid-state storage, knowing that the server will disappear. Basically, because it's free, it's included with the VM, it's crazy fast. Think 20,000 IOPS as opposed to 500 IOPS for the rest of their drives. And because they're used to treating their servers in the cloud like cattle, not like pets. If a server dies, screw it. We're just going to fail over to another SQL server somewhere else. However, the problem is if I'm doing things like log shipping, database mirroring, or always-on availability groups, whenever that dead server comes back, his data and log files may be completely gone. And it's not just a matter of letting mirroring or log shipping catch up. It's a matter of restarting it again from scratch. As a senior DBA, you're probably thinking, oh my gosh, why on earth would I even bother doing that? Because that sounds suicidal. Because it's so cheap. Check this out. These are Amazon's newest PCI Express solid state instances. This is how much the whole VM costs with your solid state storage. So you can get an 8-core box with 61 gigs of RAM and 1.9 terabytes of PCI Express solid state storage, like Fusion IO or Intel's drives. 62 cents an hour for these things. That's pretty crazy cheap, knowing that you can go that fast. Microsoft has taken the wraps off a brand new set of instances that do allow this. They're not available in all data centers yet. That's actually a gig I'm working on 3 weeks from now. Whenever these hardware vendors bring out these fancy pants new kinds of VMs, new solid state storage, new PCI Express storage, the gotcha is you just can't vMotion your guest over to one of these brand new fancy pants images. What you have to do is set up log shipping or database mirroring or anything like that to go get your data onto those new fancy drives. Guess what? You're now the one who's on the hamster wheel of the cloud. As a database administrator, you're the one who's constantly reacting whenever these vendors bring out faster and better instance types. So to recap what we talked about, platform as a service is a lot like virtualization was several years ago. On-premises virtualization has been around for over a decade now. It was initially popular with large companies who wanted better resource savings, and at first we did all the administration with point-and-click GUIs. Now, this stuff's really mature and it hardly changes at all. Everybody uses on-premises virtualization. Cloud platform as a service, this is very different. This is really designed for people who like scripting, code, treating their infrastructure as code. Platform as a service really makes sense for developers, not database administrators. DBAs are going to be more comfortable with infrastructure as a service. That piece, just in what we covered in the last 30 minutes, this is really all you need to know to get started with the cloud today. If you're not using the cloud, if your company isn't using the cloud yet, you don't have to waste a minute of your life learning it now, because whenever it is time for you to learn it, things are going to be radically different anyway. However, just know that when your developers and architects get really excited about the cloud, they're not excited about the part that you want. They're excited about the part that they want. And you don't have to learn that until it's time for you to go deploy that, because it is changing so doggone fast. There we go for the cloud. That's our little spiel there. Victoria said, is there a need for clustering in infrastructure as a service when you use premium storage? This all comes down to your RPO and RTO. So with your RPO and RTO, if they tell you that you have to be able to survive whenever one box goes bump in the night, and if you need to be able to fail over automatically within 60 seconds, then you need some kind of automatic failover mechanism. It's not usually done with clustering. Failover clustering requires shared disk storage, and that's not what premium storage is. It is kind of the SAN, but two Windows boxes aren't accessing the same volume at the same time. What you have to do is stop all activity on that volume, like shut down SQL Server, and then mount that volume over on the other VM. So it's nowhere near as automatic as failover clustering is. Microsoft has brought out Storage Spaces Direct, which lets you do failover clustering up in the cloud. I actually haven't seen anyone do a successful implementation of it yet because it requires a whole lot of new stuff. Windows Server 2016, for example. I have high hopes that it's going to be cool at some point. It's just not cool yet. All right, now let's talk about your homework. Susie says, can you recommend resources to learn AWS infrastructure as a service as it is applicable for DBAs? Here's the thing with cloud training resources. They're out of date so fast. Like if you go and build anything like training material on AWS or Google Cloud Engine or Microsoft Azure, it's out of date within 6 to 12 months. So trainers just aren't bothering at this point. A lot of us rushed in and initially did, like I recorded a bunch of training material on AWS and it was outdated within a year. So there's not really an ROI in return on investment in recording that kind of thing. Really, your best bet is to go build a lab, talk to your company and say, all right, I want to go learn Amazon Web Services or SQL Server on Amazon Web Services. I'm going to need, say, $1,000 a month of AWS credits in order to really do this thing up right. As a rough ballpark reference, that's about what our AWS bill is, $1,000 a month for our SQL Server labs. Now we run the Stack Overflow database, which is about 100 gigs in size. We have availability groups across several different versions of SQL Server. We run like 10 SQL servers in all, not 24/7. We just only turn them on whenever we want to go do work up in the lab. And it costs us around about $1,000 a month to pull that off. Can you do it cheaper? Yeah, but you're doing with just two tiny VMs that are super low horsepower and you're not really learning anything. If the company's not willing to commit $1,000 a month or $1,000 for you to go learn this thing across the span of 30 days, then it's not really worth to go learn it now. If you want to just learn it out of curiosity, Amazon has some decent documentation. It's not fantastic, but I would also look at the AWS forums because you can learn a lot from the questions that people ask inside there.